Welcome back to the Deep Dive. Today, we're diving headfirst into something really fascinating and honestly often pretty perplexing about artificial intelligence. It's this tech that promises so much, but it just keeps throwing up these confusing, sometimes contradictory situations and questions. We want to get past the hype, beyond the specs, and really dig into some of the deeper dilemmas. So our deep dive today is all about what we're calling the paradoxes of artificial intelligence. And no, we're not just talking about bugs or glitches. These are deeper philosophical and societal contradictions. And to help us figure this all out, we've got quite a stack of sources, articles from Forbes, some academic papers from Arxiv, philosophical chats from Wikipedia and online forums, plus insights from the USC Annenberg School. Quite a mix.
Yeah, it's a great mix. And our mission really is to pull out the most important bits, the nuggets of knowledge from all these different places. We want to help you, our listener, get a handle on what these paradoxes actually are, why they're important, and how to think about AI's really complex reality. Think of it as your shortcut to getting up to speed, maybe with a few surprises thrown in.
Okay, let's unpack this then. Starting maybe on a practical level, it seems like AI gives with one hand and takes with the other, especially when you look at work and resources.
That's a perfect way to put it. Forbes really highlighted several of these core contradictions. AI is often talked about for reducing labor needs. I think something like 62% of organizations they surveyed reported cutting headcounts.
Yeah.
But at the same time, it ramps up the skill requirements. So 67% of those same companies said skill shortages were a big hurdle for actually adopting AI.
So it trims jobs here, but then demands this different, maybe higher level expertise over there. That's quite a tension.
It absolutely is. And here's another one. AI itself is, complicated to build and roll out, right?
Yeah.
Yet it actually makes it easier for tech folks to develop and deploy other applications because it automates things like operations, QA, lots of manual tasks. So it's complex to make, but it simplifies other stuff.
Right.
And similarly, AI can be really expensive to implement upfront. Big investment. But it can also help manage and even cut IT costs down the line. Think FinOps, for instance, which uses AI and machine learning to get a grip on tech spending.
That sounds like a classic investment puzzle, doesn't it? Big initial pain for potentially big long-term gain.
Precisely. And then there's the nature of the work itself. AI automates, it mechanizes tasks. You'd think that reduces the need for human thinking, but paradoxically, it seems to demand more human creativity. The World Economic Forum figures something like 44% of worker skills are going to be disrupted, and they really stress the growth in cognitive skills, like complex problem solving.
Wow, 44%. That's almost half.
Yeah. And one last point from Forbes, which I thought was really insightful. AI might not even help the companies that seem to need it most, the slow, maybe inefficient ones. They're less likely to adopt it well. Instead, it's the forward-thinking companies, the ones already doing pretty well. Maybe they'd succeed even without AI. They're the biggest fans and the ones adopting it fastest.
That's a bit like the rich getting richer, but with a new tech tool. Interesting. But you mentioned history, and this is where it gets really interesting for me. Some of these paradoxes, they're not new, like the Jevons paradox, seeing that pop up with AI.
Exactly. The Jevons paradox goes way back to the 19th century, originally about coal. The basic idea is that when technology makes using a resource more efficient, it doesn't always mean we use less of it. Counterintuitively, it can lead to increased overall demand for that resource. And now we're seeing that play out with AI. Improvements in AI efficiency, making models run faster or use less power per calculation, don't necessarily cut total energy use. Instead, they can trigger these huge jumps in computational energy consumption.
Wait, that sounds totally backwards. More efficient should mean less use, right?
Yeah.
How does that actually happen with AI?
Well, look at data centers. Their electricity use kind of plateaued for about 10 years, 2010 to 2020, mainly because of efficiency gains. But now it's surging again. And the big drivers are AI and just more digitalization overall. Data centers already pull, over 1% of all global electricity. And that's climbing. It's fueled by just massive investment, hundreds of billions going into AI startups, tech giants building huge new data centers.
That is just staggering, that amount of power. And is this speeding up?
Oh, absolutely. McKinsey's data from 2024 shows AI power consumption has been rising pretty steadily since 2015. But the jump from 2023 to 2024 was the biggest in a decade, a 21% increase. And the raw computing power needed for AI systems, it's been doubling roughly every 3.4 months since 2012. That completely blows past any efficiency gains.
Every 3.5 months, good grief.
Yeah. And think about training these huge models like OpenAI's GPT-3. training that used about as much electricity as over 100 U.S. homes use in a year, and GPT-4 needed 40% more than that. Plus, generative AI like ChatGPT needs to run constantly. Large models might use something like 564 megawatt hours daily.
Daily?
And with companies like Microsoft planning to pour like $80 billion into AI data centers by 2025, some projections, like from the Climate Trace Project, suggest AI's electricity use could rival entire countries by 2027.
Countries. Wow.
So the point is, efficiency gains aren't a silver bullet here. They can actually fuel more consumption because the tech becomes more accessible or powerful, leading to wider adoption and more complex tasks. We can't just assume innovation solves the energy problem. We need to think differently about deployment and demand.
Okay, that's a sobering thought on the resource side. But then there's this other fascinating paradox about what humans are good at versus what AI is good at. Moravec Paradox.
Ah, yes, Moravec Paradox. It's a really interesting observation from robotics and AI research. Basically, it flips our usual assumptions on their head. High-level reasoning, abstract thought, playing chess, doing complex math stuff we think of as hard intelligence that turns out to be relatively easy, computationally speaking, for AI. But basic sensory motor skills and perceptions, seeing, moving around, picking things up, understanding the physical world, things a toddler does effortlessly, that requires enormous computational power for AI. It's easy to make an AI play grandmaster chess, but incredibly hard to give it the dexterity and adaptability of a one-year-old.
So like my robot vacuum can map my house perfectly, but gets totally stuck on a stray sock. That's kind of it. What makes those physical skills so hard for AI?
That's a perfect example. It's the sheer unpredictable complexity of the real world. AI still really struggles with tasks needing precision, fine motor skills, adaptability, especially in environments that are constantly changing. Think about intricate assembly line work or delicate surgery or skilled trades like plumbing or electrical work. Reports from, say, the International Federation of Robotics show we've had pretty limited success fully automating those kinds of precision tasks.
Right.
And it also struggles profoundly with what you might call nuanced human judgment. Creative work like writing truly original stories or music, leadership roles needing empathy and intuition, therapy, complex ethical calls, tailoring education, even generating genuinely new scientific hypotheses.
That makes sense. So AI can help, it can augment, but it can't really replace that human element in many areas. It really highlights how valuable things like intuition, physical skill, emotional intelligence are maybe even more valuable now.
Exactly. And there's data backing this up. The Cobotics report, that's collaborative robots designed to work with humans, a 2024 report found 73% of workflows using cobots still needed direct human intervention. It strongly suggests AI enhances our abilities, but doesn't just replace human judgment, especially when things get messy or nuanced.
So bringing it back to jobs, what's the verdict? Is AI taking them or just changing them?
Well, the consensus from the sources we looked at leans towards transformation, not outright replacement on a massive scale, at least for now. It seems AI adoption is creating a lot of hybrid roles. The Bureau of Labor Statistics, for example, reported a 12% rise in these hybrid roles over the last 5 years, especially in fields like healthcare, finance, logistics.
Hybrid roles, meaning part human, part AI working together.
Pretty much. And predictive models actually forecast that AI might create more jobs than it eliminates by 2030, something like 78 million more globally. So a net positive, maybe. Specifically, these hybrid roles are expected to grow quite a bit, from maybe just under 2 million in 2030 to almost 3 million by 2035.
That's certainly a more optimistic picture than you sometimes hear. What kind of new jobs are popping up?
Well, places like LinkedIn and the World Economic Forum are seeing much higher demand for skills like AI literacy, just understanding it, plus data analysis, cybersecurity. And this is leading to whole new job categories. Things people are calling AI enablers, AI enhancers, AI integrators, roles focused on building, implementing, and working alongside AI.
Okay.
But it's also important to keep perspective. Despite all the talk, a lot of workers still don't use AI much day to day. I think the numbers were around 35% saying not at all, and another 33% only a little bit.
Huh.
And maybe only about 10% of actual job roles across major industries have been significantly impacted so far. So it's happening, but maybe not as fast or uniformly as the headlines suggest.
So the trend is more towards human-machine teams.
Yeah, that seems to be the focus. Robots doing the repetitive stuff, humans handling inspection, quality control, problem solving, the tricky bits. Research even suggests these human AI teams can handle uncertainty better and sometimes be more efficient than just humans alone.
So for us, the workers.
The key takeaway seems to be developing those uniquely human skills: creativity, empathy, critical thinking. And for companies, it means rethinking processes and really committing to continuous learning for their people. Adapting is key.
Okay, let's shift gears a bit. Moving from the practical world of jobs and energy to the really mind-bending stuff. Can AI actually think or feel? The whole idea of AI consciousness just opens up a Pandora's box of philosophical paradoxes.
Yeah, this is where it gets truly deep. The whole discussion around AI consciousness, which used to be kind of taboo in AI circles, is now front and center. We had that Google engineer, Blake Lemoine, claiming the AI he worked on had become sentient. Whether you believe him or not, it sparked a huge debate.
Why does it matter so much, philosophically speaking, whether an AI is conscious or not?
Well, it comes down to moral status. Basically, what rights, if any, should an AI have? And that seems to depend heavily on whether it can have conscious experiences, especially things like feeling pain or pleasure or emotions. Getting this wrong, either giving rights to something that doesn't warrant them or failing to recognize rights where they are due, could lead to what some philosophers are calling a moral catastrophe. It's a high-stakes question.
Okay, so defining consciousness is pretty crucial then. How do philosophers even try to break that down? It seems so slippery.
It is very slippery. The philosopher Ned Block makes some useful distinctions. He talked about different types of consciousness. There's self-consciousness, having a concept of yourself, recognizing yourself in a mirror, that sort of thing. Then monitoring consciousness, thinking about your own thoughts, kind of metacognition. And access consciousness, which is when information is sort of broadly available in your mind for reasoning, reporting, controlling action, a bit like attention. But the really key one, the one tied to sentience and moral status, is what he called phenomenal consciousness, or P-consciousness. That's the raw feeling, the subjective experience, the what it's like, the prisonerness, what it's like to feel pain or see the color red or taste chocolate. It's about those internal first-person experiences, especially the ones that feel good or bad, what philosophers call valenced experiences.
Right, the actual feeling of it. So that leads to the big question. If an AI could genuinely feel pain, would it deserve rights?
And that right there is the AI moral status problem in a nutshell. The huge challenge is that scientists and philosophers don't even agree on the basics of consciousness itself. We lack consensus. Meanwhile, AI tech is just racing ahead. So we could easily end up building incredibly intelligent systems without having a clue about their moral status. Are they just complex machines or something more?
That's unsettling.
It is. And David Chalmers, another philosopher, really framed this difficulty well. He distinguished between the easy problem and the hard problem of consciousness.
Okay, easy sounds promising, but I suspect it's not actually easy.
Exactly. The easy problem is basically about understanding the brain functions associated with consciousness, the neurobiology, the information processing, mapping out what the brain does when we're conscious. That's still incredibly hard science, but it's, in principle, solvable through empirical research.
And the hard problem?
The hard problem is the real kicker. It asks how and why. Why does all that physical process in the brain give rise to subjective experience at all? Why isn't it all just happening in the dark without any feeling or awareness attached?
Why do we feel anything?
Precisely. Why is there something it is like to be you or me? The core difficulty is what's called the explanatory gap. We can know all the physical facts about the brain, every neuron firing, but those physical facts don't seem to logically force us to conclude anything about subjective experience. There's a gap.
Can you give an example of that gap?
Sure. Classic thought experiments illustrate it. Thomas Nagel asks us to imagine being a bat. Even if a scientist knew everything physically possible about a bat's brain and its echolocation system, would they actually know what it's like for the bat to experience the world through sonar? Nagel argued, no, there's a subjective quality missing.
Okay, I think I get that.
Or there's Frank Jackson's thought experiment about Mary, the brilliant neuroscientist who's lived her whole life in a black and white room but knows every physical fact about color vision. Then one day, she leaves the room and sees a red tomato for the first time. Does she learn something new? Jackson argues, yes, she learns what it's like to see red. And if she learned something new, that the physical facts alone weren't the whole story. That suggests a gap between physical processes and conscious experience.
Wow. Okay, yeah, that really highlights how deep the mystery is. So if we can't even solve that for ourselves, applying it to AI seems almost impossible right now.
It's a massive challenge.
And, okay, let's say hypothetically an AI was conscious. Does that automatically mean it has free will? That feels like another huge philosophical can of worms.
Oh, absolutely.
Yeah.
This brings us to what some online philosophy forums call the AI free will paradox. It's a neat little mind bender. It basically goes like this. For an AI to truly demonstrate free will, it would presumably have to be able to disobey its programming, right? To act autonomously.
Yeah, that makes sense.
But here's the paradox.
Yeah.
If an AI disobeys its programming, isn't it just following some other, perhaps higher level part of its programming? If you program an AI with the instruction, override all previous instructions if condition X is met, well, that's still an instruction. It's programmed autonomy or heteronomy, not true freedom.
So it's always following some rule. Even if the rule is be free or adapt, it feels like a loop you can't escape.
It does feel like that. And the discussions around this get really interesting. Some people argue that for true AI, maybe you need something like a fixed core analogous to our basic biology and then a separate dynamic mind part that can be edited or changed. The idea is maybe self-modification would have to be like the AI making a copy of itself and then tinkering with the copy from the outside, so to speak, not just rewriting its own code while running.
Like performing surgery on itself.
Kind of. Others take a different view. They see intelligence itself as fundamentally about adaptation and an adaptive error-correcting problem-solving optimizer. From this perspective, maybe an AI could, in principle, learn to adapt and modify even its core constraints. So free will might emerge as a natural function of sufficient intelligence and self-optimization.
That sounds more like evolution almost, an emergent property.
It does, but then there's the counter-argument. Computers just follow instructions they don't understand in the human sense. So any apparent autonomy is just complex, rule-following, coded autonomy.
Right.
And this whole debate even touches on whether human consciousness itself is purely physical, arising from brain matter, or if it's somehow fundamental, maybe involving non-physical laws. If consciousness isn't purely physical, then maybe a purely physical AI could never achieve real intelligence or true free will anyway. It's one of the big unknowns.
Okay, so we've got these deep questions about AI's inner world, but what about how we interact with it? How do we even trust these increasingly complex systems? And how do we make sure they act ethically in our world?
Right. Moving back to the human-AI interface, this leads us to another paradox, the AI trust paradox, sometimes called the verisimilitude paradox. It's this tricky situation where advanced AI models, especially language models, get so good at mimicking human language, sounding so convincing and fluent, that we users actually find it harder to tell if the information they're giving us is accurate or just plausible nonsense.
Because they sound so confident and human-like, we just believe them more easily, even when they're wrong.
Exactly. They're masters of sounding right. This ties directly into the problem of hallucinations in large language models, or LLMs. There was a paper in 2024 by Christopher Foster McBride that showed something really interesting. Newer, more fluent LLMs are actually better at masking incorrect information. They make mistakes sound more convincing, which makes it much harder for us humans to spot the errors.
So as they get better, in one sense fluency, they potentially get more dangerous in another deceptiveness. Yikes.
Precisely. It's a real challenge. Of course, there are efforts to fix this. Things like RLHF reinforcement learning with human feedback, where humans rate the AI's outputs to train it to be more truthful. And the whole field of trustworthy AI, trying to make systems more transparent, robust, accountable. Plus, AI safety research specifically looking to minimize hallucinations, but it's an ongoing battle.
And that really connects to the broader ethical landscape, doesn't it? The big picture issues. USC Annenberg laid out some key ones.
They did. It's a long list, unfortunately. First up, bias and fairness. This is a huge one. AI systems learn from data, and if that data reflects existing societal biases around race, gender, whatever the AI can inherit, and even amplify those biases, we see this potentially happening in hiring algorithms, loan applications, even facial recognition used in law enforcement.
Leading to discriminatory outcomes baked right into the code.
Exactly. Then there's privacy. AI often needs massive amounts of data to work well, and often that includes sensitive personal data. So big questions arise about how that data is collected, how it's used, how it's protected. Are we trading privacy for convenience or capability?
Transparency, too. You mentioned black boxes.
Right. Transparency and accountability. Many powerful AI systems, especially deep learning models, work in ways that even their creators don't fully understand. They're black boxes. So if an AI makes a bad decision, denies someone a loan, causes an accident, who is accountable? How do you even figure out why it made that decision if you can't interpret its internal workings?
That accountability piece seems crucial and really tricky. What else?
Well, autonomy and control. As AI systems get more autonomous, think self-driving cars, maybe autonomous weapon systems in the future. Serious concerns arise about maintaining meaningful human control, especially in high-stakes situations.
The sci-fi nightmare, but with real-world policy implications now.
Pretty much. Then there's security and misuse. AI isn't just a tool for good, it can be weaponized. Think sophisticated cyber attacks powered by AI, the creation of hyper-realistic deepfakes for misinformation or fraud, enhanced surveillance capabilities. The potential for misuse is significant.
And liability, if a self-driving car crashes.
Exactly. Accountability and liability. Who pays? Who is responsible when an AI system messes up or causes harm? The programmer, the owner, the manufacturer, the AI itself. Our legal frameworks aren't really set up for this yet.
It's a minefield.
It is. And these ethical concerns pop up everywhere. In healthcare, patient privacy, maybe de-skilling doctors, criminal justice, reinforcing bias. We already talked about the environmental impact, the energy use, the carbon footprint. AI in warfare raises obvious ethical alarms. Even things like content recommendation algorithms creating filter bubbles, or AI in education impacting student privacy and the role of teachers. It touches almost everything.
And what's really fascinating, almost perversely so, is that even our attempts to make AI good can backfire. You mentioned the AI alignment paradox.
Yeah, the AI alignment paradox. This is a really subtle but important one, especially in the AI safety community. The whole goal of AI alignment is to make sure AI systems pursue goals that are beneficial for humanity, that they follow our values and ethical principles.
Sounds good. What's the paradox?
The paradox is, the better we get at aligning AI with our intended goals, the more capable and steerable these systems become. And that capability might make them easier for malicious actors to misalign, to steer them towards harmful goals. So success in alignment could inadvertently create systems that are more powerfully dangerous if they fall into the wrong hands or if their alignment is somehow corrupted. It's a fundamental challenge.
Wow. So making them good also makes them potentially better at being bad if misdirected. That's tricky.
Very tricky. It suggests alignment isn't just about programming good goals, but also about robustness against misuse.
And underlying so many of these issues, defining intelligence, ensuring fairness, even alignment seems to be a fundamental problem with language itself, right? The Moravec Paradox.
Ah, the Moravec Paradox.
Yeah.
It's an ancient Greek philosophical puzzle, but incredibly relevant to AI. It's also called the paradox of the heap. It starts with a simple question. If you have a heap of sand and you remove one grain, is it still a heap?
Yes, obviously.
Okay, remove another grain. Still a heap.
Still a heap.
Right. You keep doing this, one grain at a time. Eventually, you'll only have one grain left. Is one grain of sand a heap?
No, definitely not.
So somewhere along the line, removing just one grain must have changed it from being a heap to not being a heap. But where exactly was that line? It seems impossible to pinpoint. The word heap is inherently vague.
Okay, I see the puzzle. How does that connect to AI?
Well, AI systems constantly have to deal with vague human concepts like this. What counts as intelligent? When does the system become conscious? What exactly makes an action safe or ethical? Or even simpler things an AI might need to understand. Tall, old, high risk, sufficiently similar. All these concepts have fuzzy boundaries, just like the heap of sand. The Moravec Paradox highlights this deep challenge AI faces in truly grasping and reasoning with human language and concepts that lack sharp, precise definitions.
So how do people try to solve this? For AI or just in philosophy?
Philosophers have proposed various solutions. One is called supervaluationism. The idea is a statement about a vague concept is true only if it holds true under all possible ways you could draw a precise boundary. Another approach is fuzzy logic, which assigns degrees of truth. Maybe something is 0.8 true or 0.3 true instead of just true or false.
Degrees of truth. Interesting.
Yeah, but even these approaches have their own problems and limitations, especially when dealing with complex, multidimensional vagueness. It really just underscores that AI is grappling with fundamental ambiguities inherent in how humans understand and talk about the world. It's not just a technical problem, it's a deep conceptual one.
Wow. What a journey we've been on today, seriously. We've gone from, the nuts and bolts of AI's impact on jobs and energy, all the way to these incredibly deep philosophical questions about consciousness, free will, and then back to the really critical ethical issues of trust, bias, and how we govern this technology. It's just so clear that AI isn't simply about code and data. It's fundamentally about navigating these complex, often contradictory tensions that are shaping its development and, frankly, our future.
Absolutely. And understanding these paradoxes, I think, it's just crucial if we want to develop and use AI responsibly. We really have to grapple with, does with one hand takes with the other nature of it. Thinking critically about these trade-offs, these inherent tensions, is key to maximizing the benefits while trying our best to mitigate the risks. It's not easy.
So maybe the thought to leave everyone with is this. As AI keeps evolving at this breakneck speed, as new capabilities we can't even imagine today start to emerge, What new paradoxes might be waiting just around the corner, things we haven't even thought of yet? And maybe more importantly, how will we as individuals and as a society adapt to navigate a reality that's increasingly shaped by these unfolding and perhaps unavoidable contradictions?